Hello students, welcome back to my channel. In this video I am going to discuss about drift velocity. Clear? Okay. So previously we studied that in the absence of external electric field, the electrons are in random motion. That means if you take it as a conductor consists of so many free electrons. These free electrons will be struck to the positive ion and again it will be moves. Okay, like that it is to be moving. So what is the direction of the electrons in this direction? In the absence of external electric field, the electrons are to be moving in random motion. Clear? Okay, so that we already discussed. Here the external electric field is to be 0. Okay, so this is the case. Okay, so in the absence of electric field, electrons are in random motion. Electron in a conductor or in random motion. Okay, so I am going to find out the average velocity of all the electron in this conductor. Okay, so first of all I am going to consider an ith electron. An ith electron have a velocity VI. This is the velocity of the ith electron. Clear? Okay, then if I will take out the average velocity of all the electron, so how can I take? Average means sum of all the velocity divided by total number. I am consider there are n number of electrons are to be there. That means capital N number of electrons are totally there in a conductor. Okay, so what we are to be taken? So we will take it as average velocity. So we will take it as V average. We will be take. Okay, V I average. Okay, VI average is equal to what? Summation of VI where I is equal to 1 to n capital N divided by capital N, where n is what? Total number of electron. Okay, don't be confused about this is a capital letter N. Okay, there is a small letter N is to be coming. Okay, this is the capital letter N. Okay, then so what about this? You see that if an electron having this direction velocity, there will be this direction velocity is there. So velocities of all the electrons are to be nearly to be equal. Okay, so we will get the direction is to be different directions. So the net velocity is what? It will be a 0 value we will get. Okay, so we will get it as VI average is 0. So in the absence of external electric field, the average velocity of all the electron is to be 0. Clear? Okay. Now we are going to apply an external electric field. So what will be happen to this conductor? We are going to see. Okay. Then so we'll take the conductor. In this conductor, we are going to apply an external electric field by connecting a potential difference. Okay, this potential difference will produce the electric field in this direction because here all positive charges, here all negative charges will come. Okay, so due to this, what will be happen? There is a electron will be shifted towards this direction. So the electrons is to be like this. Why it is shifted? Because these electrons are now in the external electric field. This external electric field will experience a force. Okay, so what is the force experienced by the electron? Experience by the electron in electric field E. E is how much? That is F is equal to what you will get? The charge into electric field. Okay, charge into electric field we will get. What is the charge? Minus E into E. Clear? Based on the Newton's second law, the force is equal to ma. So this we will equate to this and we will get it as minus E is equal to ma. From that A is equal to what? Minus E divided by m. Okay, this is the acceleration caused by the electron. So initially it having the velocity something va. So now it is to be what happened. Okay, so this velocity is to be changed. Okay, now we will see about what will be happen, that we will see. Okay, so electron got an acceleration A is equal to minus E by m when electric field is applied. Due to this electric field, the electrons are shifted towards the positive side. That means it is to be moving in the opposite direction of the electric field. That is to be saying about this minus acceleration is in the opposite direction. Clear? Now what happened? So due to this, the velocity of the electron is changed. Velocity is changed. Okay, so what is the velocity now? Velocity of the electron velocity of the electron we have to be taken as ith electron after the application, after the electric field, after the application of electric field after the application of electric field. Okay, so what will be happen? So initially the velocity is vi. Now it is to be changed to vi dash because v is equal to u plus at. Okay, so that vi is equal to vi initial velocity minus v is equal to u plus at. That is the initial velocity. Here acceleration is a into t. What is the t? T is the application of in which this acceleration is causing. Okay, so the electrons are to be collided with the positive ion. Again it is accelerated. Again it is collided. Okay, so the time of collision is very smaller, and the application of this electrostatic force is to be happen in between the collision. Okay, so this we will be consider, that is to be I am taken Ti. Clear? Okay, so this is the thing. So now we will go into what is the Ti? Time gap between the collision. Okay, now what is the A value? Vi dash is equal to Vi minus EEm by Ti. Clear? Okay, this is the velocity of the ith electron. Now we are going to find out the average velocity of all the electron. Okay, so Vi average Vi dash average. Average is equal to what you will get? Vi average minus E will be changes. M is to be constant. Ti average. Okay, clear? Okay, this is the thing we will get. Then what is this value? We already got this value is to be 0. So Vi average, this average velocity we will call it as drift velocity Vd. Okay, Vd, drift velocity. Drift velocity Vd is equal to what? This is 0, 0 minus E by M. This tau average we will call, this T average we will call it as tau. T average is equal to average. We have to be taken as tau. What is tau? Tau is the average value of all the electrons time gap. That is, we will call it as relaxation time. Okay. So what is the drift velocity formula? Drift velocity is equal to minus M by tau. Okay, what is this minus sign meaning? The drift velocity is in the opposite direction of the electric field. Okay, if we will take out the magnitude of drift velocity, what you will get? M by tau. Clear? That is the magnitude of drift velocity. Okay, so we will define what is drift velocity. How this drift velocity got? When the electric field is applied, it is to be collided with a positive ion. Again it is accelerated, so that what will be happen? Velocity increased. Again it is to be collided with a positive ion. Velocity decreases. Again it is accelerated. So finally it got a constant average velocity. Okay, so we will define it, drift velocity. Drift velocity. It is the velocity gained by an electron when external electric field is applied. Okay, that is the drift velocity. What is the symbol for that? Vd, and its formula this. Okay, it is the velocity. So it is the average velocity. It is the average velocity gained by an electron when the external electric field is applied. Okay, clear? This velocity is to be a constant velocity. Okay, that's all about the derivation of drift velocity.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like and share.